Hello friends, I'm your professor Dr. Hina Sheikh, back with you again to clear some more concepts of chemistry. Clearing basic concepts of chemistry help build the foundation, and this foundation will help you to clear all the competitive exams including NEET, JEE, UPSC MPSC exams. Not only this, the higher level exams of lecturership, SET, GATE, CSIR Net. Also, it will help you to clear practical viva or to tackle job interviews. So let us start. In this video, we are going to learn some concepts about titrations which you do in the lab. And this is your situation which happens when you deal with the questions. But if you watch the video completely, all your doubts will be solved, your foundation will be strong, and your face will not be full of sweat but with full of confidence. So let us quickly start. The first question is, why should weights not be lifted with hand? So whenever you are doing weighing, you are not supposed to touch anything with your hand. The reason of this is it causes error in the weighing because some matter may be transferred from your hand to the weight. So any weight you are not supposed to touch with the hands, neither the pair of tongs you touch with hand, neither the crucible, and the compound also. If you are weighing, you are supposed to use spatula and not hand. The second question is, why is the front door of the balance closed during weighing? So whenever you are doing weighing, you close the front door of the balance. The reason for this is opening the front door causes vibrations in the pen due to operator's breath or air currents, which leads to inaccurate results. Because of this, you have to close the front door of the balance when you are doing weighing. The next question which can be asked to you during your viva is, what is the maximum weight that can be weighed in a chemical balance? So remember, in a chemical balance, the maximum amount you can weigh is 100 grams. And how much would be the minimum amount? Minimum amount depends upon the sensitivity of the balance. Okay, so how much sensitive is your balance, that much minimum amount it would be able to weigh. Question number 4 is, what is the principle of volumetric analysis? In volumetric analysis, the concentration of an aqueous solution is determined by allowing a known volume of this to react quantitatively with another solution of known concentration. So basically, you are titrating a solution of unknown concentration to a solution of known concentration, and then your Burette reading, and with the help of calculations you find out what is the concentration of the unknown solution. The next question is, what is titration? The process of adding one solution from Burette to another in the titration flask or the conical flask in order to complete the chemical reaction involved is known as titration. Question number 6 is the favorite question of the examiner. The star mark which I have shown there means that you cannot just answer 4, you have to answer what are the type of titrations. For this, I have made a separate video because it was too huge to put everything here in this. So I have made a separate video. The link of that I have written in the description. So please go to that video and watch everything about titration in details. The next question which can be asked to you is, what is indicator? Indicator is a chemical substance which changes color at the end point. Now this answer to this also depends on which type of titration you are doing. So there are 4 types of titrations. Suppose if it is an acid based titration, the indicator changes color in acidic medium and in basic medium. So the color of the indicator will be different in acidic medium and in basic medium. So as you see the color change, you will be able to make out that the reaction has occurred. So for this also that basics is necessary, and for clearing the basic, please watch the video link of which I've written in the description box. Question number 8. What is end point? The stage during titration at which the reaction is just complete is known as the end point of the titration. Next question is, why a titration flask should not be rinsed? The answer is, this is because during rinsing, some liquid may remain sticking to the reaction flask. Therefore, the pipetted volume taken in the reaction flask will increase. So remember, whenever you are doing titration, you have to rinse. You are asked to rinse the burette. You are asked to rinse the pipette. You are never asked to rinse the conical flask, and this is the reason. Question number 10. Again a very favorite question of the examiner. What are the primary and secondary standard substances? Again, the answer to this is huge, and the answer itself will contain 100 other questions. Okay, so when you answer, you get a question, you gave the answer, you get another question based on your answer. So this is what is going to happen when this type of question comes during viva. And so I cannot cover all these things in this video, so I have made a separate video for that, so please watch that. The next question is, burette and pipette must be rinsed with the solution with which they are filled. Why? The answer is, the burette and pipette are rinsed with the solution with which they are filled in order to remove any substance sticking to their sides, which otherwise would decrease the volume of the liquids to be taken in them. So you have to remember, you rinse the burette, you rinse the pipette, and you do not rinse the conical flask. The next question is question number 12. It is customary to read lower meniscus in case of colorless liquid and transparent solutions, and upper meniscus in case of highly colored solution. So first of all, this would be your question, that which meniscus you see in case of colorless liquid and in case of colored liquid. So you remember that in case of colored liquid you see the upper meniscus, and in case of colorless liquids you see the lower meniscus. And the reason to that is, it is easy to read the lower meniscus in case of colorless solutions, while the upper meniscus in case of colored solutions. The next question is question number 13. Why the last drop of solution must not be blown out of a pipette? So this actually is an operational error. There are 4 types of errors if you have studied, which are instrumental error, operational error, methodic error, and personal error. If you want to know about these errors in details, do comment so that I can make a separate video on that, because I cannot cover all those things here. So this is a type of error. And why is it an error? Why you should not blow the last drop of the pipette? This is because since the drops left in the jet end is extra volume of the pipette, so when it was calibrated, when the pipette was calibrated, the last drop was not counted. Okay, so when you also take the amount volume in the pipette, do not blow the last drop. What is calibration of pipette? This also is a basic question which you need to know. And if you want to know the answer, do comment and tell me so that I can separately explain the calibration of the glasswares to you. Question number 14 is, pipette should never be held from its bulb. Why? Now, if you have seen a pipette, the central part of the pipette has got a bulb. A little larger part is there, broader part is there in the center, and thinner is there at the ends. The middle part, which has a broader end, is called as the bulb. We do not touch the bulb of the pipette. This is because the heat of our body may expand the glass bulb and introduce an error in the measurement of the volume. So whenever you held your pipette the next time, remember this. Question number 15 is, what is acidimetry and what is alkalimetry? It is a branch of volumetric analysis involving chemical reaction between an acid and a base. Question number 16. What is meant by the term concordant readings? The readings in volumetric analysis which differ by less than 0.05 ml is known as concordant readings. Question number 17. Can one take oxalic acid solution in the burette and sodium hydroxide solution in the titration flask? What are the limitations of doing so? So now first of all you should know what is taken usually in the burette, what is usually taken in the conical flask, what is titrant, what is titrand. So I told you already, a link is given, so there you will get all these answers. You cannot take sodium hydroxide solution in the titration flask, in the conical flask, because when sodium hydroxide solution is taken in the conical flask, the color change would be pink to colorless. The accuracy is noted this change may be less as compared to change from colorless to pink. Okay, so the accuracy is less when the colors change from pink to colorless. So usually you have a colorless solution, you add indicator, phenolphthalein, you do titration with NaOH, and the end point is colorless to pink, which is more accurate to observe. Question number 18 is, which indicator is used in the titration of sodium carbonate against hydrochloric acid, and what is the color change at the end point? The answer to this is the indicator used is methyl orange and the color change is yellow to pinkish red. Question number 19. What is the difference between an endpoint and an equivalence point? The answer is endpoint is the point at which indicator shows a visible change indicating that the reaction has completed, and equivalence point is the point at which stoichiometric amounts of the two reactants have been added. So if you want explanation of this is also there in that video. So in details properly I have explained you the difference between endpoint and equivalence point. So do watch that. Visible endpoint may not be exactly coincide with the equivalence point. Question number 20. What indicator is used in the titration of oxalic acid with sodium hydroxide? Which solution is taken in the burette and what is the endpoint? Phenolphthalein is used as the indicator and sodium hydroxide solution is taken in the burette. Appearance of pink color is the endpoint. Now how will you remember? Always remember sodium hydroxide has very good relationship with phenolphthalein. So whenever you have sodium hydroxide and it is an acid-base reaction, you have phenolphthalein as the indicator. Next question is, what is the indicator used in the titration of sodium carbonate against hydrochloric acid? Which solution is taken in the burette and what is the endpoint? The answer is methyl orange. Acid solution is taken in the burette. Change of color from yellow to pink is the endpoint. So thank you so much for watching this video. If you have any doubts, do comment and tell me. Please like, share and subscribe. Thank you so much.